Hi everybody. So we're going to talk about inequalities right now. Inequalities are important because they allow us to write infinitely many solutions in a short and understandable form. Um, so traffic signs like the ones shown here often appear in front of schools. From the sign, a motorist knows that a speed greater than 25 miles per hour breaks the law and could possibly result in a ticket. So if I put s as the speed and I put greater than 25, you could be breaking the law and you could, get a ticket for doing that. And then a speed less than or equal to 25 could result in nothing happening, right? You're following the law, and you probably won't hurt anybody if you're going through the school zone, as long as you stop on time. And with that being said, what the top one says is that if your speed is a value higher than 25, you could be any number. You could actually be 100,000 miles per hour, although we know cars don't go that fast. But you could be any number higher than 25 in that case. And here at the bottom speed, you could be going negative numbers as well, all the way to negative 1 million even. But we know that speed is generally bounded by 0 and 25, or 0, because you don't go negative speed limits. There's a little bit of notation you have to understand. If you have the not equal to sign, that's this first one. It just means that they're not equal, like 7 is not equal to 9. Less than is just 3 is less than 5. Greater than is 52, greater than 38, greater than or equal to, and less than or equal to. So hopefully you know the difference between those. Obviously, that equal to includes the bar underneath it. The ones without the little bar underneath it are just strictly less than. So you can't say 25 is less than 25, but you can say 25 is less than or equal to 25. So we're going to talk about set builder notation. So let's do this next problem. We have 2x minus 9 minus 10x is less than or equal to 3 plus 4x plus 12. So let's combine like terms. This means negative 8x minus 9 is equal to 15 plus 4x. Less than or equal to. This is going to be minus 4x minus 4x. Negative 12x minus 9 is less than or equal to 15. We add the 9. Negative 12x is less than or equal to 24. And then divide by negative 12, divide by negative 12. X is greater than or equal to 2, negative 2. So notice that I flipped around the inequality because I divided by a negative. If you divide or multiply by a negative, you need to do that. It has to do with the fact that there's multiple ways to solve this. So I could have, if I had negative 12x is less than or equal to 24, another way I could solve this is add 12x to both sides. And now I have 24 is 0 is greater than or equal to 24 plus 12x. And then I can subtract 24. So negative 24 is less than or equal to 12x. Divide by 12. And now I have negative 2 is less than or equal to x, which is exactly the same statement as this. You can't switch the sign unless, when you do switch signs, you want to make sure that the little arrow looking thing for the inequality symbol is pointing at the same number. So for instance, if I wrote x, this is not the equivalent of that. That says the exact opposite of what the other, oh, no it doesn't. Sorry, I thought this was greater. I thought this was less than. If I write this, that is not the same thing as down there. And so you have to be very careful. There's two different ways to write that. I prefer the one where x is first, and I'll tell you why when I'm graphing here in a minute. But as for set builder notation says x, x existing in R such that x is greater than or equal to -2. Oops. Okay, and that would be your set builder notation. Next, we have the following. So let's do this. We have -7. This is basically standard. This part, you just basically write what the inequality was. And it just means x is in R, it's a real number, such that x is greater than -2. That's just another way of writing it. We have -7 is greater than 16 over 15t plus 1, which means -7 is greater than, I'm going to subtract 1. -8 is greater than 16 over 15t, which means if I multiply by 15, divide by 16, then now I have, well, this is 8 and 16, that's 1 and 2, so this is 15 over 2 negative. It's greater than t, and so this is t is less than -15 over 2. Now if I were to graph this on a number line, I have a number line here. Remember 15 divided by 2 is 7.5, so you have 0 here. Let's say somewhere over here, 1, 2, 3, 4, 5, 6, 7, 8. One way you can do this is you can draw this is negative though, sorry. 1, 2, 3, 4, 5, 6, 7, 8. You can draw a parenthesis. And then since t is less than this, it must be any number to that side of t. So anything in the red is a solution to this value. Okay. And obviously this is 8 negative and this is +8. So that's how you graph these. Another thing you might have seen before is sometimes they use an open circle and go this way. I prefer this parenthesis method because, for instance, if you were to write the domain of this, you would say -infinity because it's pointing towards -infinity up until -15 over 2, and then you'd know you do not include it because you used a parenthesis on the actual graph itself. You'd use a bracket if it was less than or equal to, that's greater than, if it was less than or equal to. And you just follow the rules, basically. It's either a bracket or a parenthesis, and then that goes on. The next one to look at, we have y is greater than 3x plus 2. If we were going to do this one, we draw the graph. To graph 3x plus 2, you're going to go up 2, 1, 2. And you're going to go up 3 over 1 from that point. So we go up 1, 2, 3 over 1. Now this is a greater than symbol, so we're going to draw a dotted line. If it was a greater than or equal to, it would be solid like the following. Okay. And then, now that it's graphed, we want greater than, so let's test 0, 0. If we plug 0, 0 in for x and y, we have 0 is greater than 3 times 0 plus 2, which says 0 is greater than 0 plus 2, which says 0 is greater than 2. Which is false. So I tested a point right here, and this point is false, and so that means I shade on the other side of the line. Okay. For the next one, we have to solve it a little bit better, but we can do this another way too. For instance, let's go like this. We have 2x minus 3y is less than or equal to 6. So what I'm going to do is I'm going to use test points. I'm going to test x and y. X is 0 and x is say x is 6. No, let's do x is 3. Okay. So I'm going to plug that in. 2 times 0 minus 3y is greater than or equal to 6. So that tells us negative 3y is greater than or equal to 6, which says divided by negative 3, divided by negative 3. This tells us y is greater than or equal to negative 2. The greater than or equal to doesn't matter. We're just looking for points. If I use 3 for x, then I have 6. 2 times 3 is minus 3. Y is greater than or equal to 6, which says 6 is minus 3y is greater than or equal to 6. So minus 6. Negative 3y is greater than or equal to 0, which is y is greater than or equal to 0. So this is 0. And so if I wanted to graph this one, this is obviously just an alternative method to graphing. I put 0, negative 2, 1, 2. I put 3, 0, 1, 2, 3. This one is greater than or equal to or less than or equal to, so I'm just going to go ahead and draw that. Oops, I missed. Okay, I mean, close enough. I still missed. Hold on. Okay. Nailed it. All right, so we want to test value. So let's use the same test point. Let's use 0, 0. This is our test point. Let's see if it's true or false. I'm not going to put t because that could mean true. But we have 2x minus 3y less than or equal to 6. So if I go ahead and graph this, I have 2 times 0 minus 3 times 0 is less than or equal to 6. Which is 0 minus 0 is less than or equal to 6, or 0 is less than or equal to 6, which is true. So if this is true, then I shade this side of the line because it's the true side, and we're good to go. So notice that here this was false, so I did not shade that side. Here it's true, so I did shade that side. I hope this helps, guys. Make sure you watch the videos, make sure you practice, and you'll do fine. Thank you, guys. I'll be making some more soon.